Hi, my name is Alexa, and the topic that I'm going to be speaking about today is isostasies. So, more specifically, an introduction of what isostasies is, and then when things tend to float or sink, and how to calculate the fraction submerged and the density. So, about isostasies. Isostasy is the state of balance where an object floats in a fluid without sinking or rising. It is also the equilibrium between the object and the surrounding fluid, and this tends to happen when the forces acting on the object are balanced. So, how exactly do we know when things float and sink? In our textbook, we had an example of have you ever wondered why icebergs float in the ocean? And the reason for this is because ice has a lower density than seawater. If you see on the right, I put the density of both the ice and the seawater. The ice being 0.917 grams centimeter cube, while the density of seawater is 1.25 grams centimeter cube. So the height of floating depends on the densities of the material involved. And we're going to use this equation more at the end of the presentation and how to actually find what the average density is. So keep that in mind. So why do objects sink and float? So if an object density is higher than the fluid density, it sinks. And if the object density is less than the fluid density, it floats. So here in this example, the objects with a higher density than the liquid seem to sink at the bottom of this tub, and the ones with the lower density tend to float on top. So how exactly do we calculate the fraction submerged and the density? Most importantly, we have to know how to calculate density before doing anything else. By this, we do the volume, which is length times width times height. And then we take the mass of the object, which is just the weight. And with these two, like with these two, we could find the density, which is just the mass over the volume. So with this, now we have the actual density. And we use the density to calculate the fraction submerged or the height. So, to specifically do the percentage wise, it's just the density of an object over the density of the liquid. You get your answer and you times it by 100 to get the percentage submerged. Now, if you want to get the height submerged, all you have to do is density of an object over the density of a liquid and times it by the total height. And that's how much you get. That's how you get the height submerged. It is important to remember that the higher object density is more submerged and less elevated, so it's floating less. And a lower object density is less submerged, more elevation, and floating more. Remember, height does not affect the density of the object. The height or size remains the same. Now, for an example, so given that the density of ice in iceberg is 0.917 grams centimeters cube and the average density of salty ocean water is 1.25 grams centimeter cube, what is the density of ice as percentage of the density of ocean water? So right here is asking the percentage of the density ocean water. And if you remember back a couple slides ago, how you do that is you do the density of the density of the object over the density of the liquid. And that's what I did here. So I did 0.917 grams centimeter cube over 1.25 grams centimeter cube. And you times it by 100. And your answer, if you look on the right side on the bottom, it should be 89% submerged. That's all I have for today. Thank you.